There we go. That has started. All right. Good morning, everybody, and welcome to AgroPlus and 2020 Seed Labs. Today we have with us Moses Palmer from Nisku, Alberta. He's works at 2020 Seed Labs, and he's here to talk to us about seed testing and why it's important. At the end, we're going to do a draw for participants for a 2020 swag bag. So, with that being said, Moses, why don't you load up your presentation and we'll get into it.
Awesome. Thank you, Lau. Good morning, everyone. Thanks for making time to join the conversation today. Today, we'll be talking about the importance of seed testing. And like Lau accurately introduced me, my name is Moses Palmer. I work as an accredited seed analyst at 2020 Seed Labs, and I also manage the laboratory out here in Nisku. I do some work with Seeds Canada as well. I serve on a couple of committees on there. And I also I'm a seeker, so I have an accreditation to be able to accredit seed that is coming into Canada and going outside of Canada. So I do a couple of things in my role at 2020 Seed Labs. Today we are answering a question: why is it even important to test seed, and what is the need for seed testing? I was at Lakeland College earlier in the year where I gave a talk to undergraduate students, again, trying to answer this question and trying to build that interest in seed testing in them. And someone at the end of my presentation, one of the students asked, so why do we even have to do seed testing? Well, the simple answer, straightforward, is that as part of the Canadian pedigree seed system, it's part of the law to test your seed because your seed needs to meet minimum standards for germination and purity. And then when we deal with barley, then there is a need for a truly smart test if the seed is not going to be treated. So that is one. But then looking at things from a grower's perspective, seed testing provides you with insights. It gives you an idea of the quality of the seed you are dealing with, and then based on that quality, it gives you the ability to be able to make decisions as to whether to even use the seed in the first place, or what management practices to put in place to ensure that you have a successful crop. So bare bones, our lab, we have a couple thousand tests that we run for different things, but focusing on an average grower, we would recommend a germination test. Growers usually have a practice of screening for germination after harvest, right after harvest, so that they know what quality they have right after harvest. And then pre-spring planting, we get samples into the lab where growers are checking again to see whether the seed lots they're selecting for seeding in the spring is of the quality that they want. So germination test right after harvest and germination test recommended. Another test that we recommend is to run a vigor test, as well as disease screening, and then 1,000 kernel weights to make decisions about what your seeding rate is going to be, right? So testing your seed, we did some calculations in our lab, and we came to the conclusion that if we consider the whole production system as a whole, and what investments growers make into producing a crop, when we consider how much a seed test costs, like those 4 tests that I listed, as a percentage of the whole investment that the grower makes in terms of equipment, in terms of labor, in terms of chemicals for spraying, seed testing as an input is the lowest within that group. So seed testing, you spend very little in seed testing as compared to everything else, but the insights that you get from your seed testing can provide you with information to be able to make decisions as to whether you should spray, what kind of spraying to do, what timing of spraying to do, how much seed you should put in the ground, and all that, right? So together, seed testing is your lowest test cost input. Also, having when you test your seed and you're able to determine the quality of your seed lot, it ensures that you have uniform emergence. And uniform emergence has several implications. I'm talking to growers, so I don't need to overstress the importance of that. It affects your the uniformity when it comes to applications of chemicals like spraying herbicide, spraying fungicides. It allows when you have a proper stand, you have better weed control because the canopy closes uniformly, and so you don't have areas where you have weeds essentially taking over the field. And then also when it comes to harvest, it's easier because you have a uniform maturity, and then you don't have one area of your field that is all green and another area that is ready for harvest because the green area came up later than the other areas, right? Um, when we look at seed testing as a whole and we include aspects of seed testing like purity testing, it can help you to know whether you have noxious weeds present in your seeds, and also if there are certain diseases that are present in your seed. And this prevents you from, let's say, buying seed from somewhere that might have some noxious weeds or certain diseases and introducing it into your area if your area is free of those diseases. Again, knowing what diseases you have, and it's funny, I was relating this to some growers that I met and again at the Lakeland Agricultural Organization, and I was telling them about the fact that you can't treat. Let's look at ourselves as human beings. You can't treat a disease that you don't know you have, right? So when you know that you have a condition, then you can invest time into the management of that disease. So, and again, it's the same for your field. If we test our seeds and we know what pathogens are present on our seed, then we can plan to be able to mitigate the effects of those pathogens during the production season. So let's delve a bit deeper into some of the tests that I highlighted at the beginning of the presentation. So we talked about germination testing, and again, a germination test simply assesses the genetic potential of your seed lots to be able to produce when conditions are ideal. So when you have enough moisture in the soil, when the light amount needed for the seed to grow is perfect, when temperatures are ideal, and then when you have free gas exchange. So those are the four main conditions that are necessary for seeds to germinate. And in a germination test, we are simply saying, okay, if we have a seed lot and we provide all these conditions to them under ideal circumstances, what is the potential of that seed lot to grow? We usually express the results as a percentage. And so we would say, let's say your seed germination is 90%. And what that simply means is that out of 100% of your seeds, usually in a germination test, we are looking at 200 seeds for a Canadian test. So out of the 200 seeds, 90% of that germinated or produced healthy seedlings. Within that same germination test, we will report abnormal seedlings. So these are seedlings that have some defects to essential structures. And essential structures here refers to roots, to shoots, to cotyledons. Essentially, damage to a seedling that prevents it from growing into a healthy plant. And so we report that percentage for you as well. And then we also provide information on how many of the seeds were dead, that we found dead during the testing. And then also, we also report fresh seeds. And the fresh seeds here represent dormancy. So seeds that simply have the potential to grow, but they've taken up moisture, but they just haven't been able to produce a seedling during the germination period. So that is basically what a germination test tells you. But also within the germination test, we have the ability to be able to diagnose other conditions, and we're able to relate the conditions that the seed experienced on the field in a germination test. So in some cases, for example, we can see dormancy very easily in a germination test. So in this case, you can see that we have some seedlings that have grown, and then you still have seeds on the blotter that are just not growing. In some cases, we also see chemical damage in a germination test. And in this case, the clear distinction is that you have these roots that essentially look like spidery legs. And instead of the roots growing down into the media, they essentially attempt to grow up. So we're able to see that, and we usually see this where growers have applied a pre-harvest herbicide, probably at the wrong time, or when the seed has been in contact with some chemical of some sort. In cases where the chemical is just on the surface of the seed, we're able to regrow the seed in a soil media. And then because the soil media absorbs a lot of the chemicals, we're still able to have the seed grow. So we'll normally call the grower and say, hey, would you like a retest in soilless? And then sometimes we see an improvement in the germination. In cases where the chemicals is within the seed itself, a change in method doesn't lead to an improvement in the germination result, unfortunately. Another problem that we easily diagnose in a germination test is mechanical damage. And we normally see mechanical damage in years where it's dry, especially really dry going into harvest and just around harvest time. Usually what happens is that we see this a lot in peas and large seeded legumes like faba beans as well. So you have micro cracks. So the seed coats, because the seed is so dry, every time you handle it, every time you move it from the combine into your truck, from the truck into the bin, from the bin into your truck, to cleaning, to handling, every time we handle the seeds, we have all these cracks on the seed coats that we don't see with a naked eye. But then during the germination test, because the seed is designed in such a way that it's supposed to absorb water through one way on the seed, but because of all the cracks on the surface of the seed, you essentially have the seed taking up water very rapidly, and then it leads to rapid expansion of the seed and the cracking. So here you can see that you have some cracking of the seeds, and then you have very little growth. So if we compare the seed to the seedling to the left to the seedlings on the right, all these were planted at the same time, and they're growing on one blotter. So you can see the drastic effects of mechanical damage on the seedling development in the germination test. Another problem that we easily diagnosed in years where we have frost, especially going into earlier in the season, or where you have situations where a grower essentially is unable to harvest and at the time of harvest, and then the crop is left over winter and harvested the next year, we see a lot of signs of frost damage on the seedlings during the germination test. And in that case, you'd have just a lot of thickening and shredding of the leaves, of the primary leaves, as they come up during the germination test. So these are all the problems that we can diagnose just by running a germination test. And usually, if you have any of these conditions with your seed lots, we usually report it as a remark on your report. And so again, I'll talking to growers, always read your report of analysis. Read all of it, read what the results are, and also read the remarks, because there might be some useful information in the remark portion. And again, if you have questions, you're not clear about what you're reading, you need a bit more information, feel free to call the lab at any time. And we have analysts who are trained and ready to answer any questions that you might have. I just wanted to just talk a little bit about dormancy. So dormancy is for us growers and for seed analysts, dormancy is a bad thing because it means that the emergence and development of the seed is delayed. But for plants, it's a survival mechanism which ensures that the plant grows into an environment that is conducive for the plant, and also that the plant has a highest chance to be able to produce a mature plant and further on its generation. Usually, dormancy is as a result of an imbalance of certain hormones within the seed. And for most seed lots, usually just allowing the seed to rest and ripen is enough to be able to break the dormancy. So we usually start applying dormancy breaking approaches right from when we start receiving seeds from harvest all the way to after winter. So last month, we took off all the dormancy breaking approaches on the seed lots that were coming into our lab. And the expectation is that if a seed lot still has dormancy at this point of the season, there is nothing that we can do that to break that dormancy, especially since the grower is going to make the decision to plant that. And again, using a dormancy breaking approach at this time of the year provides a false narrative as to the potential of the seed lots to grow. And so we take off dormancy. So far, germinations have been really good. The only crop type that we are seeing some levels of dormancy on in the lab is barley, and which is normal. In that case, we're using another dormancy approach. So the main dormancy breaking approach that we have in the lab is cold stratification, or what we usually call pre-chilling. So in this case, we put the seeds on a media that is infused with water, and then we put that whole seed package with a blotter and the water into a fridge at 5 degrees Celsius, usually for about 3 days. And we find that after we bring it out of the cold and put it into the warm temperature for growth, we see significant increase in germination. And in that case, the dormancy levels would have broken because of the cold treatment. And again, it's because of this cold stratification, that's why we remove dormancy breaking approaches this time of the year, because the thinking is that the grower would have had the seeds in their bin over winter, and the seeds would have been able to undergo one, ripening, and two, some levels of cold stratification. We also have some chemicals that we use to break dormancy in the lab. The main one we use is potassium nitrate, and we apply usually a 0.1% solution of potassium nitrate to the crops to grow. We usually see quite high levels of dormancy in oats. And so for oats, we usually always go with a pre-chill and also potassium nitrate to break the dormancy. And the thinking is that because most growers would put down some nitrates at the time of seeding, that having this potassium nitrate simply replicates that process that growers would use at seeding. If all else fails, if ripening doesn't break the dormancy, cold stratification doesn't, and chemical treatment doesn't do it, then we move on to hormonal approach using gibberellic acid to attempt to break the dormancy. That's the highest level of dormancy breaking approaches that we use in our lab. So now let's talk a bit about vigor testing. So why should we test for vigor? So growers will ask, well, I have my germination results. My germination results are really good. So why do I need to test for vigor? So a vigor test is essentially designed to mimic conditions that are not ideal or optimal for seeding to grow. And then we judge the performance of a seed lots based on how well the seeds will perform under non-ideal conditions. So like I summarized here, growers usually use the germination results to determine what the best case scenario is. So if everything is ideal, if everything goes well, there's enough moisture in the soil, what is the potential of my lot to produce a healthy crop? And then they can use the vigor as a real case scenario, because we all know that conditions in the field are not always ideal. So that is the approach that we use for vigor testing. I just wanted to present some data that I came across that I found really interesting, and just to share with you. So in this case, this was a study that was done in Ontario in Dr. Finch Savage's lab, where they looked at the germination percentage of commercial sugar beet seeds. So they did this laboratory germination. Those are the dark gray bars that you see. And then they went into the field and planted the same seed lots. And so they compared emergence during the field seeding to the germination test that was performed in the lab. And right here, you can see that for each of the seed lots, the germination potentials were high. They were in the 90s or close to 100 for most of them. But when you looked at the field emergence data, you could see that For lots that were even as high as 100% germination, you still had field emergence that were as low as 75%. So what this tells us is that germination testing alone is not enough to give you all the information you need to make a decision about your seed lots, because conditions out in the field vary widely from what we see tests where we attempt to provide all the optimum conditions for growth. We realize that seeds that have higher vigor have germinate faster. And again, having that advantage of germinating faster means that you could avoid some disease stresses earlier on in the production season. It could mean that for years like this, where we expect it to be quite dry, it means that seeds that germinate faster are able to germinate into enough moisture early in the season compared to seeds that take a longer time to germinate, which might miss that early amount of moisture that we need for good crop establishment. Also, seeds that have high vigor have narrow spread of germination time. So you have seeds, they are faster to germinate, but they also germinate uniformly and they emerge evenly as well in the field. Another approach that growers could use results from a vigor test results to do is to determine the quality of the seed lots, especially during storage. So I just put in this graph just to give you an idea. So usually when in the germination test, if a grower tested their seed lots over, let's say, 5 years, they were testing for germination every year for 5 years. The seed lot eventually will start to decline. The germination will start to decline over time. And that is expected because physiological aging will cause the quality of the seed lots to reduce and deterioration. But that decline that we see in a germination test, it's gradual, it's really slow. But in the same time, if we were testing a vigor with a germination test for that seed lot, we would see a sharper decline in the vigor earlier than we would see in a germination test. So it tells us that we're able to detect deterioration in a seed lot faster with a vigor test than we do with a germination test. So if you are doing those two tests at the same time, you get a sense very quickly of how your seed lot, the quality is dropping in the vigor than you'd see in the germination test. Here again, I just wanted to present you with a scenario, and we see this a lot in the lab. So this is soft white wheat that was planted for germination test in our lab. The germination results came in at 91%, which is very good. We had 7% abnormals and 2% dead. So if a grower was making a decision about using this seed lot alone based on the germination test, this seed lot is good to go, right? But when we ran a vigor test on the same seed lot, we find that the vigor results are a lot lower than the germination test. And in this case, the vigor was 75%, which tells us essentially that when the seed is stressed out in the field, you would expect your germination or the emergence to be as low as 75%. For seed lots that are of high quality, we expect to see the vigor results within 5% of the germination results. So if you had a 91% germination, we'd expect to see the vigor to be around 86%, 85, 86%. So that would be good. But in this case, it's 75%, which is way lower. So a grower making a decision to use this seed lot for growing is taking on a lot more risk in case situations are not as we would expect out in the field. And there are several different vigor tests that have been deployed in the labs, especially they are crop-based. For cereals, we usually go with a cold stress test. In this case, we expose the seeds to cold temperatures, 5 degrees, for usually 3 days. And then we put them in the warm and see how they're able to grow. We're usually doing an assessment of just the roots, seeing how quickly the roots are growing under those cold conditions. But for different crops, for canola and peas, they all have different approaches that we can use to measure what the vigor test is. And again, we have different growers who test with different labs. Now, my advice, as always, is to find out from the lab what is a vigor test and what is the thinking behind it, and how does that vigor test relate to your very specific field conditions. So I think growers should be asking those questions of the labs. Now let's talk a bit about disease screening, and I'll focus on again three diseases that it's really common. So fusarium head blight is one that we've known in Alberta for so many years. It was recently taken off the Alberta's Agricultural Pest Act, which means that growers essentially now have to make that decision as to management by themselves. Is this a seed lot I want to take the risk to grow even though it has 1% fusarium, or am I essentially not doing fusarium at all? If I have a seed lot that has any level of fusarium, I'm completely rejecting it. That is a decision that has been left to growers to make. Our advice is that you test your seed for fusarium, because even for years like this, where we expect it to be dry, drier than usual, growers will usually say, well, it's going to be dry. There is no need for fusarium testing. I would say still test for fusarium, because when that crop is grown, you still have levels of the fungus that grow, and then you're essentially creating a fungal pool for the next crop. The fusarium bodies will live within the stems that are left on the field and the seeds that drop. And then if the next year you have ideal conditions for the disease to grow, then you'd have a bigger explosion of the disease in your field than you would have if you had tested and chosen a seed lot that was fusarium free. So again, we have two main tests that we run in our lab. We have the fusarium plate tests, which is a standard test where we soak the seeds in some bleach solution to get rid of the fusarium spores that might be on the surface of the seed, and then we put it on a media and plate it for 7 days, and then we count how many colonies of fusarium we are seeing on the media plate. We also have a DNA test. It's slightly more expensive, but that is faster. It gets you results within 3 days. And again, our recommendation that we give out is that for areas where we know fusarium is already endemic, we recommend that you do a test plate, so that a plate test, so that you have an idea of what levels of fusarium you have. And then for areas that do not have fusarium, we ask that you do a DNA test, because the DNA test gives you an indication whether fusarium is present or absent. So again, you can send us fusarium seeds. We can run the tests for you in the lab, and you can select it as part of a package. I just wanted to show this image because it's really interesting to me. We see on the right side a germination test that was done with a seed lot that had high levels of fusarium infection. And then again, we called the customer wanted us to do some seed treatment. So we did some seed treatment on the left, and you see a drastic improvement in the germination. So going into this season, what we are offering to growers is that we're offering them the opportunity to do a side-by-side testing of their seed lots without a seed treatment and with a seed treatment of their choice. So if a grower, let's say, wants to use a particular seed treatment, they can tell us, we can get that, and then we can do a side-by-side germination. Again, just to give you an idea of how using a seed treatment like that could improve your testing, your seed quality.
Moses, before we move on there,
Yes.
what would you consider a high content of fusarium on the seed? What levels are we supposed to be hitting the warning bells there?
I think having any level of fusarium on your seed should raise a warning bells. But in the lab, we typically see fusarium levels at 1% to 1.5%. I think generally growers are a bit tolerant with fusarium around the 1% level. Anything above that should give you some cause for concern.
Very good. Thank you.
So bacterial leaf streak is a relatively new disease. It's becoming one that there's been a lot of focus on recently. It's also called a black chaff disease. We see it a lot in cereals, with wheat, durum, triticale, and usually you have because it's a bacterial disease. It's more driven with moist, warm conditions. But it's becoming something that a lot of growers are asking to check. And the recommendation is that if you know that it's not currently present in your area, um, we ask that you do the testing so that you don't introduce it into your area. Currently, there is no treatment that has been recommended, but there's a lot of work currently ongoing to be able to bring out some recommendations on how to treat it. There are management approaches like doing crop rotations, planning your rotations so that you're not doing a cereal and then a cereal right after each other, which most growers don't do anyway. But then testing is one approach. Again, knowing what you have could determine what you do. So I just presented here a graph of testing that we've done since last year, August. And then we see that we had varying levels of Fusarium detected, Xanthomonas detected for seed lots that came into the lab. So we had about 47% having moderate levels. Another question that I get when I show this graph a lot of times is, what does high level mean? What does moderate level mean? What decisions do I make about this based on the result that I have? And how does the level of detection relate to disease incidence and severity in the field? So those are questions, because the disease is relatively new. Those are still questions that we're trying to answer. We're currently working with Agriculture and Agri-Food Canada with Kelly Techington based out of Lacombe to do some trials to determine at what levels. So we have medium, low, high levels, but at what level should growers be concerned, and at what levels should growers be making a decision as to whether to use the seed lot or not. So that is still in decisions in testing. For now, if you scouted your field and you found some bacterial leaf streak symptoms, we would ask that you send us a plant. So you can pull maybe between 5 and 10 plants that are showing the symptoms, send it to the lab, and we'll be able to do some testing for you. Again, just wrap it in some moist paper towel, or put it in a in a Ziploc bag, and then just send it to us. You don't need to cool it or put it in a cooler to send it to us for testing. And then I'll end with Aphanomyces root rot. So again, this is an important disease in peas. We see it's a complex, but the main pathogen in there that's causing the disease is the Aphanomyces itoiches. And what you normally see as a result of the disease is it usually affects the seedlings really early in the growth stage, and you have the extensive damage to the root. So here we're comparing the left plants are plants that were not growing in soils that had Aphanomyces, and then the right seedlings were growing in soil that were infused with Aphanomyces, and you can see the difference. The root growth is severely restricted on plants that have encountered Aphanomyces, and essentially these seedlings will not be able to grow as well and produce healthy plants. And then in the field, if you were scouting your field, you'd see patches like this where you have some areas that are really yellow with seedlings that are dying, and then areas that are doing good. Again, because it's a root complex, and then the disease is soil-borne, you have the disease in different parts of the field. Again, our recommendation: we do a lot of testing for Aphanomyces in the soil, but we also do Aphanomyces testing in plants. So if you come across plants that are showing symptoms like that, you can pull some plants, send it to us, and we'll be able to do the testing and give information as to what you have. We also have disease experts in our lab who will be able to provide extra information to you as to some approaches you can use for disease management, and also to introduce a testing strategy that will be able to provide you as much information as you need going into the season. So that is all for my presentation. Again, reach out to the lab if you have any questions. Call the labs, send us a message through our support emails, and then we'll be more than happy to respond.
Very good. Thank you, Moses. Anybody have any questions for him? Sam, I know you have a mic.
I have a bit of a question, actually. If you can hear me. Can you hear me?
Yep.
Yes,
Yep,
we can hear you.
Okay. So if a seed test is submitted in the fall, are you using those dormancy breaking methods on the test, and will we know whether or not those methods have been used? For example, like if we need to maybe retest in the spring?
Thank you, Mallory, for the question. It's a really good question. So in the fall, we're using dormancy breaking approaches. It's usually presented as a portion in the remark that says that dormancy potassium nitrate was used to break dormancy in the seed lot. So there would always be a remark on your report that tells you any changes or any modifications to the standard methods that we use for testing. And so that would be in there, and you can look at that and make a decision as to whether going into the spring you should use that. But again, if you have questions about whether a dormancy breaking approach was used or information on the reports is just not clear enough to you, please feel free. We are always happy to talk to growers, and sometimes it feels lonely when we don't hear from growers. So give us a call and let's chat about it.
And we get a lot of questions on substandard results, like 70 to 80% results on germ or vigor. How does a producer know when too low is just not to use it? Maybe that's a crazy question and most farmers know that, but if you get a germ of 74% and a vigor of 78, is that worthy seed to put in the ground, or is it risky? Like, there seems to be no graph to show borderline low high.
Yeah, I agree. I agree with the question. It's one that I've had to attempt to answer on a phone call with growers several times. And again, you said there's no guidelines, specific guidelines that we can go to and say, for this at this level, it's recommended not to use the seed lots. What I usually say is it's up to the grower and how much risk they are willing to take. I've had growers who would adjust their seeding rates with, let's say, a 75% germination test in the seed. They put in more seed to make up for the difference in the germination tests. But then again, unfortunately, I don't have the answers as to be able to say 75 or 65% is the absolute level where you shouldn't use the seed. And like you said, most growers have an idea of, based on experience, what levels how low they would go in terms of a germination result tests for selecting a seed lot. So I don't know if that answers your question. I'm not sure it does, but
No, it doesn't, but I understand why you're not answering it. Lyle, do you have any comment, or you dare to answer that, or what do you tell guys when they show you a seed results like that? Is it up to the producer?
Yeah, generally when I'm running, seeding recommendations, I'm going off the vigor, not necessarily the germination rate. And I mean, sometimes it can be a huge difference. Like if you see some like peas with mechanical damage, or they've been, they were harvested too dry, that 25% difference between germination and vigor can mean, upwards of an extra bushel for seeding. It can be pretty high, and sometimes it's just not worth it, especially when, the price of the seed is really high.
Lyle.
Yep.
It's basically the same question in a sense, but I got a germination of 75 and a vigor of 84.
How's that work?
So
it's
we
a box method that they did.
So you were was it a lentil then?
Was it what?
What crop type was it?
Chickpeas.
Chickpeas. Okay. So chickpeas are notorious for, we see differences in germination and vigor results for chickpeas and lentils a lot, and faba beans. So what happens is that sometimes you might have, because the chickpeas and the Chickpeas in a germination test usually go for 14 days. And we usually plant them usually in sand, and they stay in that sand for 14 days. What happens is that when you have some levels of dormancy on the seed lots, in a germination test, by the 14-day period where we are doing the final evaluation, those seeds would have stayed in the soil and would have become rotten and died, right? And so in your final germination test, you might have it at 75%. But when we do a deep box method, we have a pre-chill component to it, which breaks dormancy. And so sometimes you might have more seeds because the dormancy is breaking earlier on in the vigor test. You might have higher levels of germination. You might have your vigor being slightly higher than your germination. And again, it's just because the germination test is warm conditions for a long period, 14 days, 2 weeks. Seeds end up dying and becoming seeds that do not grow end up dying in the germination test. Whilst in the vigor test, you have early dormancy breaking and seedling emergence higher in that case. So that would explain something like that.
I see.
Any more questions?
One other question, Moses. There's been some talk about checking seed for nutrient levels by another lab in Canada. Can 2020 test seed for, call it nutrient level or nutrient loads, to show any significant deficiency on a nutrient?
Currently, we do not offer those services. There are partner labs that offer that service. We could always put you in touch with a grower like that. But for now, our focus at 2020 Seed Labs is just focusing on the seed quality testing, like germination, vigor, disease, and then some other quality tests like dawn testing for the presence of mycotoxins, and then falling numbers test looking at sprouting damage in cereals. So that's where our focus is currently. We're not yet into the nutrient testing parts of seed testing.
Thank you.
You're welcome.
Has anybody here had their seed tested for Phanomyces yet? Or anybody submitted a soil sample? I haven't heard of anything yet, but if you guys are starting to suspect it, see it out in the fields, it would be nice to do a few tests this year. It can be visually difficult to tell the difference between that and fusarium at some points, so until it gets really bad. But I have seen some field patterns which would lead me to believe we do have some Phanomyces in the area, but we'll probably see more of it if we have a wet year. Okay, well, if there's no further questions, I'm going to stop the recording here, and then we will do the draw.